Good morning, dear students. This session we will talk about portal frames having sway. So how we solve portal frames having sway using Kani's method. Okay. So first let us derive the quantities which are required for the solution of the frames with sway. Then we will go for procedure and an example. Okay. So there are two cases in case of frames having sway. So case one, we will take up. The case one consists of height of columns is same in a particular story. So this is a case, and another case we'll be dealing is having height of columns different in a particular story. So this is case one, and that we will deal it as case two, right? So to incorporate the sway quantity, the sway moments into this the Kani's evaluation procedure, the present discussion is required. Okay. So what do we do now? So to incorporate sway moments into this now iterative procedure like cyclic procedure, some of the things are required. Those things we'll be deriving now. So please concentrate. So consider rth story of a frame shown below. So we have some number of stories here. Let it be 10 or 20 or 30, whatever it may be. That take particular story, that is rth story. So r being story number. So R may be either 1, 2, or 3, whatever it is. So I am considering a particular story here, and now I am taking free body diagram of a particular column in this particular story. So this is column PQ. You see it here. I've drawn free body diagram of this one, complete free body diagram with all possible reactions, horizontal, vertical, moment. So I have given clockwise direction for moment for the positivity of this one, positive nature, and vertical reactions to balance sigma of y0 and to balance horizontal forces are given opposite nature, sigma of x0. Okay, so H at end P is equal to H at end Q from sigma of x0, that I'll call it as simply H. Okay, right. HR is the height of that particular rth story. Okay, height of the story, nothing but height of column. Now take moments about the end P and is equal to 0, make it equal to 0. So if you take moments about this point P, V at P vertical reaction pass through this point, so moment is 0, and VQ also pass through this point P, so moment from VQ is also 0. H P is equal to H is passing through the point P, so that is also 0. So only HQ, which is equal to H into HR. That means clockwise moment. So clockwise moments are written positive. So H times HR is the only moment from loads, and the other moments are the moments developed at the ends, that is end moments. MPQ, MQP are the end moments, both are clockwise. So clockwise positive is taken. So even if you want, you can have a notation like this. considering clockwise positive equal to 0. So now the horizontal reaction from this expression is equal to these two goes to right hand side and become negative, and HR comes to denominator. So this is a horizontal reaction developed in the column, nothing but column shear force in the column for a particular column. So similarly, you take all columns in that particular story, summing horizontal forces in that particular story. So sum of all such columns. I have three columns here, this one and this one, this one. So adding those three horizontal, this is horizontal force, I mean reaction or shear force found in column PQ. Similarly, we have horizontal force or shear force in other column. Likewise, any more columns if you have in that particular story, we will be adding them. So we will be having sigma MPQ and sigma MQP divided by, as height of column is same, HR remains same. So this is called story shear. So the horizontal total horizontal force in that particular entire story is story shear. So story shear calculation is sum of end moments, top and bottom. This is top end moment, bottom end moment. All sum of all top and bottom end moments of that particular story divided by the height of the story will give you story shear. Okay. Similarly, SR into HR will become minus sigma MPQ sigma MQP. Let it be 1, and this expression will be using for further derivations. Okay. Now let M star PQ be the additional moment caused due to sway. So till now we have not introduced any sway moment. Okay, so now final moment become, so what is the end moment expression for us? Fixed end moment 2 times near end rotation contribution plus far end rotation contribution. Now sway moment will also contribute to end moment. Okay. Similarly, bottom end fixed end moment 2 times near end rotation contribution, far end rotation contribution. Also the sway contribution or moment from sway. Okay, right. Now if there is no load acting on the column, for example, so fixed end moment due to loads will be 0, because if you have say particular column and there is no load acting on this particular column, the only load is acting on the beam, let us say. So MFAB and MFBA both are zeros. Okay. So adding equation 2 and equation 3 and taking no load condition means what? Fixed end moments are to be made 0. This is to be made 0 because there is no load. And add these two, MPQ plus MQP means sum of top end moment, bottom end moment of the column. So what happens? You have M dash PQ here also. So this is 2 times and this is plus 1, totally 3 times M dash PQ. Similarly here, 3 times M dash QP and M star PQ plus M star QP. So that is written here. So these are the sum of end moments, top end moment, bottom end moment, 3 times top end rotation contribution, 3 times bottom end rotation contribution, and this is sum of sway moments, top and bottom. Now applying it for all the columns, this is for one column PQ. So what happens? We have to make summation of all the columns in a particular story. Okay. And taking is one more condition. Moment due to sway is same. This we know very well. So if a particular column is having sway, right, the moment developed due to sway is same in nature and also same in value. 6 EI delta by L square. Okay. So same in value. So these two values are same nature. So I will simply write 2 times this. I can write 2 times M PQ instead of writing MPQ MQP because these are same, equal to MPQ equal to MQP. So I can simply write 2 times MPQ and delete this one and remove that one. So such 2 times sigma M star PQ will be there for all the columns. This is for one column, this is for all columns. Okay. Now bring this one, this term to one side, remaining all the terms to other side. So what happens? This end moments total minus 3 times the rotation contributions top and bottom total. Okay. Now what, there is 2 here. So send this 2 to the other side. It will become 1 by 2. Sorry, sigma m star PQ is equal to 1 by 2 times the sum of end moments minus 3 is there. So this term minus 3 divided by 2 will come minus 3 by 2 times sum of top and bottom rotation contributions. Okay. So we have this term equation 1. Let us take it from equation 1. You see here. So sum of end moments is nothing but SR story shear into height of story. So substitute that instead of this one. So SR HR divided by 2 minus, okay, right, and minus 3 by 2 times sigma M dash PQ plus sigma M dash QP. Okay. Now let us see as this is the expression that we have written. Okay. So as SRHR, this here you see why the negative sign has come here. You see we have this expression sigma M PQ sigma M QP, so that this negative sign goes to the other side. So minus SRHR is equal to this sigma MPQ sigma MQP. Hence this is negative. Okay. So this is the expression for total sway moment in that particular story. Okay. Now what? Right. You see minus 3 by 2. This minus 3 by 2, I'm taking it outside. So what I need here? 3 I need. So I multiply with 3 and divide it 3. So what I need? Minus 3 divided by 2 is outside. So what is remaining? Yes, R H R by 3 is remaining inside. So minus also gone outside. So plus sum of top and bottom rotation contributions in that entire story. Okay, total top and bottom rotation contributions. But what we have for sway moments, we know the value 6 EI delta by L square. Okay, if the sway is towards right. So let us take, because we have taken the sway values as taken to the right, sway to the right. So minus 6 EI delta by L square. And finally, it will be 6 EI delta by L square. So for the expression to have minus 3 by 2, let us take 4 included in this expression, 4 divided by 4. So what is that? Minus 6 by 2 will become minus 3 by 2. So to accommodate minus 3 by 2, we are introducing 4 into this expression. So minus 6 by 4, and remaining is 4 EI delta by L square. So 4 EI by L, I'll write it as a single term, delta by L another term. So it will be 4 EI delta by L square. So minus 3 by 2 k times delta by L. This is nothing but 6A delta by L square only. But to have the form of minus 3 by 2, we are formulating like this. Similarly, all such columns will have the similar expression. Minus 3 by 2 is common. If you add all k values, it will be sigma k. Delta is same for a particular story, and height is same. L is nothing but height of the column. Right. So now if you divide this and this, so m star pq divided by sigma m star pq, minus 3 by 2 cancels out and delta by L cancel, it will be k by sigma k. Then from this I can write m star pq is equal to k by sigma k into this k by sigma k, and this goes to the numerator sigma m star pq. Okay, so that you substitute in this equation 5. Okay, so it is m star pq divided by k by sigma k, and this is the right hand side of equation 5, this one. So where this goes to the numerator here, minus 3 by 2 k by sigma k. This is what m star pq, that means sway contribution, sway moment, SRHR by 3, story moment we call it as, and sigma m dash pq plus sigma m dash qp. What is this one? Top rotation contribution, bottom rotation contribution of all the columns in that particular story. And here, whatever we got the term minus 3 by 2 k by sigma k in this derivation process is called as displacement factor. Okay, so displacement factor is defined as minus 3 by 2 k by sigma k. And story moment in the process of derivation, we have got SRHR by 3, which is taken as story moment. Okay, so these are the expressions required in the process of derivation. These terms we will be using in the iterative process. Okay, right. Further, okay, the displacement contribution is just now found. Displacement factor, that means minus 3 by 2 k by sigma k, is replaced with this notation. Story moment, story moment, rotation contribution at top and bottom ends of column in that story, all the columns in that story. And how do you get rotation contribution? It is very similar. A rotation factor multiplied by sum of fixed moments at that joint plus foreign rotation contributions, all foreign rotation contributions for that joint, and also all the sway contributions related to that joint. Okay, sway moments related to that joint. So that is how you find rotation contribution. Okay, so with these expressions, we will be able to solve the sway moments. If the frame is having sway, we will be able to solve using Kani's method. Okay, so this is the example that we will be taking up in the next session. Okay, thank you.